Hello everyone, welcome to the stream. Hey DFTA, hello Ray. Welcome to the stream. I hope Twitch works right away today. Maybe we can test the new Home Assistant notifiers for that. I'm curious. Johnny helped me to set this up yesterday with his plugins. So let's take a look. Home Assistant. How do I see that? Settings. Let's see. Settings. For devices services. What is it? Let's not dox ourselves here. YouTube live, but no, I want Twitch. Twitch, bitluni, 5 entities. Okay. Status, nothing. Detected running. No, that's yesterday. Not running. Hey Sonic. Johnny, plug in says it's not running. What is going on? Here is Johnny. Here comes Johnny. Here. Today's string of the day booster, not affiliated. 0 sugar. That's negative calories in some way or form because I'm burning more when I drink that. And it's walking. Like in German, es geht. Der geht! Alright. Engine oil is negative calories, what? Hey cat. Hey the shippo. Alright. Unfortunately, yeah, we need to see. Johnny is investigating if it works or not. You know what else is not working? No, I'm joking. Here, look at that. Look at that beauty. Look at that beauty. You see that the pads? This is what we need to program today. A solar panel. Yeah, almost. It's 512. It's an array of 512 MCUs and 17 FPU controllers. Here, look at that. This is and it's here. There is the test interface, but I'm stupid. I should have soldered the power connectors to the other side, because when I plug it in, look at that. I plug it in. I won't be able to program. Oh, Caspar. Hey, Jordi. Okay. Solder station. I needed both. I tell you that. What is the red connector? What red connector? There is no red. That's jumpers. I can use the jumpers also to supply power. That's just I have different power lines that I can disconnect. If I plug in 3.3 volts or whatever, I have several power lines. So I have separate power for this controller. I have separate power for these controllers. There are like 2 lines, I/O and core voltage, and I have separate like 4 different power lines for 4 sections of these controllers here. Just so I can isolate issues or whatever. That's a whole half blade because the whole blade wasn't a wasn't possible to be manufactured because it was too many components, too big to everything. It let the JSC servers crash. They were not able to manufacture this. Hey, the Moray effect is nice. Look at that. Anyways, yeah, we will have like two blades next to each other. Let me show you that. I have also. I mean, this single blade here is 100 euros. I think it was what 100 euros one blade. Here is more. There is still the frame is still on here, and there is one unpopulated. That's cool. Collectible for me. Maybe I will put them in a frame at the wall because I'm proud of my creations. As you should be. So in the final assembly, there will be like right next to each other, and this will be like one blade. Like the initial plan was to have this as one blade, more like this way around. So we had like controllers, but that didn't work. So I just split them, and here we go. It is what it is. Now we have those, and if you look closely, because Caspar was asking if I needed the soldering station or I don't need the soldering station. Who was Caspar? Yeah, hello Caspar. Here we go. Maybe you spot it when it focuses. There is a botch. I show you the botch. There is at least one botch already. So I have to fix something. It is so embarrassing. It is so embarrassing. Yeah, that's why we don't manufacture 128 blades at the same time. We test it with 4 and see what the issue is. Let me turn on the microscope, and you will maybe spot a botch. So I have to adjust the circuit, which is unfortunate. I didn't want to touch it. Now I have to touch it. For the order, I will split the final order to one that goes out immediately, because I have still, what is it, almost 8,000 MCUs, so I can manufacture a few of those blades with adjustment. So if that goes wrong, I only lose 10,000. I have to fix not like 100 boards. I have to fix only like, I don't know, what is it, 7 boards. Here is the microscope. Let me turn it on, and you might be able to spot a botch. Do you see it? Any guesses what happened? Actually, they are not stacked. Anyone knows what happened here? But we have also good news. No worries. Yeah, Stonehenge. I should record this. Yeah, Stonehenge is a good guess. So, what do you think happened? Tombstone configuration. Mixed up TX and RX. Yeah, the Shippo, you're the winner. So, I don't know how we missed that. I will show you on screen. Every single time, yeah. I'm so glad I left these 50 ohm resistors there because this way this botch was alright. It took me only 1 hour for the blade, and I have only 4 blades with this arrow here. Um, Let me show you this obvious thing. You know what? Whoopsala. Here we go. Unlike with UART, SPI, I don't know. I don't know how we missed that. I mean, this is not like I changed anything the last day before the order. I have no clue. And the issue is, the same mistake happened on my test board that I had, like this small section. This same error is there as well. And I just noticed today because, let me turn on the camera. No, this is not the camera. Let me show. Here. So, yeah, I have this test board. The same mistake was here. I only tested if the signals are working and everything. What I didn't test, I didn't test the complete hardware SPI configuration. And there is where I spotted, let me stop it for a second. This is where I spotted that the meso signal, whenever CS was turned on, it dropped to half the voltage, which means that both sides are pushing and pulling, and thanks to the 50 ohms in the center, like in between on that line, it wasn't a short. Yeah, that was the only reason that it wasn't a short. And yeah, then I realized, hey Basil, you missed the fun part, the blade here. This is the blade. Anyways, yeah, too bad, huh? And now the issue is, if I want to fix that, I have to do it minimal invasive. So I will probably, I don't know how to, yeah, I will probably route basically that line like that and put this one here. So we don't have like a lot of change here, and yeah, it is what it is. It's not like super perfect, but it it will work. I'm so thankful that the clock signal is here and Meso and Mosi are next to each other. And my solution to that is quite cool because, I mean, it's embarrassing, I know. Crossover IC, yeah, I maybe could. But, hey, Tsisani. Um, I thought even like, oh, maybe I can just order a PCB that is of this size or whatever, or a thin PCB with just the crossing vias, and I cut it with scissors. That would be all possibility that I thought about. But then I thought, oh well, it's only like 4 boards. I don't want like to order broken boards. That's obvious. It's a slight change, and I can fix another issue with the order where I just place the wrong caps at the crystal of the row controllers, which is optional. That's why it didn't matter that much, but I can fix that for the next order as well. So, alright, I mean that's a minimal change, and I have the space to route the stuff here, and it's only like 16 of those to change and be thorough with it and order like the next batch while I try to obtain the remaining MCUs, the remaining 50,000, no, 60,000 MCUs. All right, yeah, this is, I don't know how that happens. You know what the best part is? I missed obviously this part. This is blade level 0 is this here. Okay, so if we look at the hierarchy, this is the lowest level. No, what? No, that's, sorry. Here, blade level 0. Open the wrong sheet, yeah. So this is the little MCU, which you would see here, like this little MCU. This is that. Then we have the next, the level 1. This is where the mistake is. This is basically the connection between the row controller here, this big MCU, and the small MCUs here. This is the mistake. And then we have the higher level. This is where the SPI from these controllers is communicating with this controller. And look at that! When I designed this part, I looked up even, I think I prompted even Gemini, and it assured me to be sure that I have Miso and Mosi the right way around. And I did it here correctly. So this doesn't need a fix, but all of those. Okay, so obvious question. Paranoid? Yeah, Basil, you're completely right to do it, and it's always the wrong way around the first time. No matter what you do, I mean, I did so many, for 12 years I'm doing the projects, and every single time RxTX is flipped in some way or form. I mean, the last one, you remember my, here. The last one was the M.2 matrix. I mean, that was like the precursor, the test project for the cluster, for the M.2 cluster. And I had TX and RX also flipped because it was wrong in my footprint. Because you have like the footprint of the M.2 slot, you can have the perspective either from the host and from the client side. And there was like one, I don't know, there was a flip in RxTX. Usually you can exchange them. I don't know why it was an issue in this case, but there was also a flip there, so yes, and that didn't work. And now again. Anyways, we spotted it before I need like to fix 128 boards. Who's the master? Yeah. Yeah, client and host. Let's call it like that. Anyways, easy fix. I tombstoned. I put, if you look closely here, let me sharpen that or zoom further in. Can we, can we sharpen that picture? You can't see it well. Okay, so I put one of the 50 ohm resistors diagonally across. You know how small that is. You know how small that is. I show you a 0 ohm resistor. And do I have one? Like an 0603 resistor or component. Because I thought, all right, I will put I will put one 50 ohm across diagonally, and then I will tombstone one of the 50 ohm resistor and connect it on from the other side with a 0 ohm resistor. So I have still the 50 ohms from both sides, and there is a good connection. And this one is already tested, so I even found an arrow there with the multimeter, and I will maybe here. Do I have a? Where are my 0 ohm? Just for comparison, how tiny that work was. And my new soldering irons were performing excellently. So I used the bigger one. Here, this is the with the knife blade. Here, the what is it? IFN to remove the resistors, and then this one. Yeah, I repeated that work for one blade 16 times. That took me an hour, and I have 3 more blades, so it's another 3 hours, but I got better at this. So it's probably, with testing, it's probably like 2.5 hours to fix the 4 blades that I already have. And the next ones will be ordered without that mistake. Yeah. It's funny. It's so embarrassing. I don't know. Alexei, if you're watching this, now you know. It's content. It's content. It's cringe. Because I always earn respect for my engineering skills, and then things like that happen, and then all the respect is gone in an instant. You know how it took me, like when I looked at the oscilloscope and saw that whenever CS was turned on, the meso signal halved the voltage. Flux smoke, yeah. When I saw the voltage halved, and I read the data sheet before that, whenever CS is asserted, it will put the meso pin, the client puts the meso pin into push-pull mode. And when I saw the voltage like dropping to half of it, and then the signal was still there, something that never, that all the people did that mistake at some point. So it's not even like unique. But whatever, when I opened the data sheet, it took me not even 1 second to spot it here. Like not here, but blade level 1 here. Just to spot it. Like when I saw that, I thought someone exchanged my data sheet, like in a Truman Show. This was the feeling of a Truman Show. It must be kidding me. How did that happen? I instantly saw that, like within 1 second, and then when I went thoroughly through that for ever and ever, and it took me months to design that, and I didn't see that even after I designed, like, I don't know, I missed it even after I designed like the upper level, which doesn't have that mistake. And I assured, oh yeah, that needs to be connected like that, and then never checked the other thing. And I thought it works because we tested the signals but I never like completely did a transfer, whatever. But however, the new fix, look at that. Oh, upside down, unfamiliar, like rubber ducky development. Okay, that's a new method. I need to consider that in future. All right, so One bummer that so now we can use the hardware SPI. It works. Our test board is transferring. As you see, you probably don't see the flicker, but it's very fast. Like this MCU transfers data to the host, and this is how it looks like if we let it run. Yeah. Oh, it's very fast. Uh, it's basically incrementing, and the host is sending the data back, and it took like 2 frames. 2 frames. Yeah, you see 73, 71. It took 2 frames like to bounce the data because there's the buffers and so on, and in the order of receiving and transmitting. There is one slight bummer that we the not doxing here anything. All right, here. Our little MCU. It has an 8-byte FIFO for that, but it doesn't work full duplex. You switch the FIFO either to receive and transmit. So that's very unfortunate. The hardware implementation. Oh yeah, by the way, there was always, because the question, can you change the GPIO matrix to flip the signals with that? There is no option for that on these MCUs. I checked all the, because if you switch either master or client mode or master slave mode, basically the functionality is flipped anyways, but there is no option for that, like with a register flag. You would we could put them like both in master and then it would work. But the issue is you can't. It would be like using tricks to make it work with the chip select. So the chip select is meant for I think there is a mode where you can, where the client can wake up the master or whatever with the chip select. Might be there might be a mode, but that would be a bloody hack, and since it is like a minor fix right now that I can do, and I really don't want like to trick there, but there is no way of flipping the GPIO matrix or whatever and fix it like that. There was the possibility to basically bit bang SPI, like do a software implementation. It would only affect one side. So in that case, we could choose to use basically the row controller to implement like a software implementation of SPI with the row controller. It is several times faster than the little ones. No, it isn't. Wait, yeah, that is 100 megahertz. I think it is. The SPI works. It says half the system clock frequency of FSys. So 50 megahertz is the maximum speed for that. Yeah, alright. I mean, and that's 120 without the crystal. It's slightly faster, but also, like, there are a few optimizations with this MCU where a software implementation wouldn't matter that much if we don't want to use it for calculations ourselves with the FPU that's in the row controller. So there would be a workaround, but I don't want to use it. I rather fix it now and then be good. Use the hardware thing. Anyways, now I also asked Gemini for because I want a suggestion how to. Hey, also. I want a suggestion to how to program over SPI. Maybe there was like a mode or whatever that we could use, and Gemini basically suggested that we do our own bootloader or a stub in the beginning of the. Maybe I can show that. Look at that for a second. Don't want to show you all the yeah, that's your name now. Pop. Where is it? Oh, I think I used the other account. No. Hey. Ah, yeah, here we go. Yeah. Okay, so can I write the flash? Wait, no, that wasn't the start. I want to program. Oh, that I even that I typed it while still in bed at 6 in the morning when I woke up. Blah blah blah. Here, let's start from here. Okay, so blah blah blah. Programming methods. There is no SP ISP with SPI, so the method would be write small program that resides at the start address, basically configure whatever flash and then jump after that, and whatever program I upload, I would need like to that's quite helpful. I mean, that's just an orientation. That's the programming thing. Verification here. Oh, nice. Film extractor. Yeah, that was, I think I asked it, how to reset the stack, because, yeah, that's we need to clear any interrupts, and then stack pointer. Stat address. Yeah, I know. But I don't want to dox your location or whatever. You're still a minor. Replace the regular bootloader is an option. But I don't know at what circumstances it starts in the bootloader. Usually I think it starts at the address 8K, 8 whatever. Oh. Oh, at 2000? Wait, let me check that. You would need like to enable boot pin or whatever to put it in the bootloader. And this is something, but I'm open. Basil now, if you're the expert. I mean, I completely forgot, but if someone knows how to do it. Alias. Okay. Okay, let's go. Claude, using. I want to use the French guys. We can do that. Okay, Basil. That is. This is our task list for now is to make a bootloader that initializes SPI and initializes also the status LED. Oh, initializes two SPIs. One that. Wait, no. No. Initializes the receiver SPI from the host. Waits for a command, and the command will be either boot or program flash. So if we power cycle, it always will wait for a boot command. Otherwise, it will wait for flash, or I don't know. Maybe we add later diagnostics or whatever. Okay, how do we do that? I have, let's say this is level. Oh, let's check that. That's no issue here. Option bytes. Wait. That's that. MC. We can check that. Oh, it's 8,000. Yeah, that's what I thought. Size. Yeah, so that's what happens. You need I think the boot pin that determines what section. I think it says at the end somewhere like the boot pins here. Boot flash option bytes. No. Okay. User option bytes. No. Okay, the main memory can be erased, program, blah blah blah. Ah, shoot. Memory allocation, bootloader. Yeah, that's what I think. Yeah, boot pins. Yeah, you need to use the boot pins. There is startup, boot pin system is reset, or power is reset, the value of boot. Otherwise, you need like to do a soft, like a jump or whatever into the bootloader. Start them off the value boot pins, system is reset. We would need like to change. Oh, nice for you. Boot pins. Tiny. Yeah. All right. From system memory address will be mapped to the address area. Oh, interesting. SRAM is 2. That was wrong with blah blah blah. That's F version. Yeah, there is no such thing. I guess DRAM. No, I have no time whatsoever to look at any other device than my own one. Uh, Sorry, this is like I'm delayed. Also, reduce the amount of text, please. It's a little bit much on TTS. Otherwise, I would need to rate limit you in surveying form. Oh, dude. No, you need the timeout. Sorry. 5 minutes. Here we go. All right. He's so I like if young people are excited, but just too much text in that doesn't add to the project. It's unfortunately too much for my ears and it blocks my brain. So a little. Hey, Quindor! We used the soldering stations. It was perfectly necessary to acquire those. Yeah, we botched already. We botched already the new blade. Do you want to see the botch? Here we go. Miso Mosey flipped. Yeah, no, it's all right. You didn't miss anything. We were waiting for the board. This is how the new board looks like. This is 512 MCU cluster board and the interface board. You did too. Everyone, no matter how long you are there, there is always RxTX. It's a rule. The rule of electrical engineering. It's always the other way around. So yeah, this is. What do we want? All right, we are looking for a way of doing a bootloader, but in that case, I think there is no way around. You fixed it twice? Yeah. Fu! Hello! Welcome! Fu, did you see? Yeah, I used both. I had like the big knife from the iPhone to remove the resistors, and the tiny knife, the tiny one from the other, to solder them back on. Fu, this is for you. Look at that. Yeah, TXRX. If it was only TXRX, it was Miso Mosey. Anyways, this is already botched, so this blade is botched. Now the thing that we want to do is now I have some code already for the SPI that works. We can send SPI data and yeah, there is no way that you need to use the boot pins. This is I think you would need to Yeah, but then if you brick your device, there is no way you can software reset. So I would actually configure the firmware to be uploaded like that. The issue is, what do we do? Do we wait, before we do that, let's use that task. Okay, new tasks. There is plenty of tasks here, but yeah. New task. Task would be SPI bootloader level SPI bootloaders, and that are different ones. So subtask is level 0, level 1. Let's give it some space here. Level 1, level 2 is basically the same. Level 2, it's just a different SPI. So level 0 could be different, since we are working with the CH570, which has a different design. Can show, wait, startup. Okay, so the thing with the 570 is it has a really slow flash. So anything that is time critical is put into RAM, and that's copied in the bootload, the startup. I think these are the interrupts, I think. Yeah. Global start, handle reset. Okay, so this is the start thing. What we can do is that's the default handler. What we can do is we can load high code section from flash to RAM, load section from flash to data section, clear, whatever. Like charge a gap on the boot pin and then reset. I won't be doing any hardware things there. Charge a cap. But then you need like to have that code running, and the boot pin on the bigger ones has no GPIO functionality. Yeah, I don't want a software issue if we can fix it in hardware. I could do that. We discussed it already. There is no GPIO matrix. I could bit bang from the host controllers. But yeah, I rather fix it now and be good. I mean, it took me an hour for one blade. I have 3 more blades to fix, and then the next issue will be with fixed Misomosi. Anyways, this one works a different way around. Yeah, you're late. No worries, no worries. I just update everyone who just joined. So if you look at the main code here, every flag that I have high code flag, so this whole method will be put by the linker script into, is it here? Link sections high code. It will be put in the high code section, which is then copied into SRAM later. We have only limited SRAM, but basically the CH570 already utilizes a lot the running code from from SRAM, which is quite cool, because in that case you could everything SPI related. I put it in high code here. So high code, except for init SPI client, whatever. We can put this also in high code and 2K. What? No, it's 12. We have plenty of SRAM there. 12K. Which is alright, otherwise I wouldn't be able to implement, you remember the analog TV thing? Yeah. Yeah, that works. Oh yeah, by the way, here you can see you need to swap the direction if you want to receive or submit. And this is a crude implementation because it doesn't utilize the FIFO really well. It only... Yeah, this is alright. It waits for the next byte to receive, so it's blocking. And this one... No, wait, sending. Oh yeah, it only sends one. This we could change that to, I think, 8. So if it's... while it's greater equal to 8 or whatever, then we should wait. Otherwise we can write to the FIFO. I believe this was the implementation from SPI slave send byte, and I have a different naming convention, that's why. And we are I think I did loop. I moved it to the front, otherwise it would wait inside the loop until the master basically did anything, but we can process different stuff. Send can wait. Yeah, currently I also wanted to test the other directions from the client to the host. That's why I implemented only like incrementing here and sending, but we can do basically the same, just receive it and do the set the LED to the color. We can program that. That's easy. Whoop! With my test article, that's quite simple. And now we need to program the other one. The level 1. Level 1 has, I think, bidirectional, like full duplex, 2 FIFOs. They are so stingy. 8 bytes. Damn. Even with DMA, the FIFO is required to be either attached to receive or transmit. So when we have like the protocol, we need to put the client there into read mode. Just send the command and then it will put itself into read or transmit. Or we should always put it in read, but once it's like if you want to fetch data from the client, it will put like with the command, it will put it in receive, and then I mean in transmit, and then do whatever it needs to. I don't know. Weird. Can probably, how does, yeah, we need to implement basically SPI, a communication stack for that. I can put this on the list. Half duplex call SPI protocol protocol half duplex so basically what will be what is that sub go oh, can't read it, it's quite half duplex and then we can do either duplex character. Funny. Oh, by the way, did you ever wanted to know how 50 SATA cables look like? This is how they look like. Did you ever wanted to know how 100 SATA cables look like? Did you ever wanted to know how 150 SATA cables look like? This is how. There is oh, I mean, you witnessed when we ordered this stuff. This was the $5 heatsink. Look at that, with heat pipes and everything. That actually looks usable. It has like stuff and attachments and whatnot. It's very light, but it will probably do its job. I mean, we just ordered it out of curiosity. Yeah, it's crazy. Also, oh yeah, I don't know if I showed it before. These are the round ones, huh? With fans. They're like $3 each, and we have 2 bags of that. For 40 or 50? 40. And 40 of those. We need that. This whole room is filled with components, and I still will receive plenty. Yeah, anyways, okay, half duplex communication concentrate. So how do we do it? The host, oops, wireless mouse for £3, yeah. Okay, so host sends command, and then what is the command structure? Yeah, if it works, it works. Like, especially mouses. Oh, Casper, there is a way, because you can set up in full duplex mode, you can set up the DMA or fill the FIFO with data. So basically, if you can imagine our FIFO is 8 bytes long, we can basically set the comment to be always 8 bytes long. And what happens is that if the client needs to tell the master something, or the host, it would just fill the FIFO and the SPI would automatically push out those bytes whenever the next frame is overlapping command. Yeah, I mean, you need to distinguish. You would need to distinguish if it's a dummy byte, because in full duplex mode, it's always sending data no matter what, and it can be 0, it can be FF, whatever. So if we have, like, let's say there is a data ready. Ready is basically, let's say, DD. That would be data ready, and when the client is done with calculations, it would send like data ready, and then 7 bytes of data or information, how long is the data, whatever. Then the host would do a poll. This is like clients. It's maybe we should do a protocol. Host can basically poll. That can be basically poll that, let's say, poll would be 69 and 0 0 0 0 0 0 0. That's our frame, 8 bytes, because we know that would be something, the FIFO length, and we want to optimize for the hardware. And then basically len 0, len 1, 0 0 0 0 0. Okay, that's that. Or we have like only a 7-byte result, so special result client, something like that. And that could work full duplex, but we don't have full duplex here. In that case, I would assume that we have a timeout. Maybe, I don't know how to write the list. Okay. Client always in receive mode. Receiving toggle clocks. That means Mosey have some data. Oh yeah, that. No, they basically pass by. This data is already. Okay, I mean, we can. That is in the FIFO, and the client is doing different stuff. When the poll from the host is received, it's placed in the FIFO. I mean, if it was full duplex, it would place that in the FIFO, and then at some point an interrupt or whatever would trigger the client to read, oh yeah, here is new frame coming in with this and that. But still the host will receive the message from before, which was placed in the buffer, in the FIFO buffer, that there is data ready, and the host can decide, oh yeah, that was only if it was only a poll, the host knows, oh yeah, I need to fetch some data. If it was like, oh, here there is like new firmware to upload, then it would never fetch the data that is ready. Yeah, so full duplex is actually possible here. We don't need to implement it first, like especially between level 1, 2, and 3 and whatnot, since these MCUs support that, but the lowest level doesn't support it. So we will implement like a half duplex method to be always in read mode. Let's check SPI here. This is interesting, but I wanted to do another thing today. Maybe we can do it still. That is um, programming the blade with stuff. Okay, what do we have? Supports full duplex synchronous serial mode. That's what we can do. Supports blah blah blah. Half DMA. What is the buffer size? RX buffer and TX buffer. So that's the FIFO. Oh no! It's not called. How big is the buffer? That's I2S. Doesn't say. That's I2S, SPI. Back from timeout. Okay, no more irrelevant stuff in my ear, please. CRC control register, maybe there is receive. I don't know where the buffer is specified. Doesn't say here. Let's do the filtering here. Nobody knows if it doesn't have a FIFO, huh? So it probably, yeah, we need to do DMA. Otherwise we will always have like an issue. Oh wow. And then CRC. All right. Okay, so actually that's harder to do that than the other one, because with the FIFO ChatGPT Rec No, I'm not using ChatGPT right now. What is that? Useless? Yeah, I think they are just too popular now. You need to use those AIs don't who are trying hard to gain traction. They don't scale down the performance. I'm wondering if we don't use FIFO, we don't see the hardware structure like here, but if there is basically, if you switch to send mode, if you can still receive yeah, so no FIFO there. You need to use the DMA. SPI buffer, SPI enable, transceive. CAN bus. That's also a communication bus that's used in cars, for example. But it's slower than SPI. Clear. I think there is only bit order out if DMA loop clock select. FIFO overflow. Flag. That's good to know. Single byte transmission complete. There might be a way to do if there, I didn't see. Yeah, that's a receive and transmit buffer. But I'm wondering if there is like the register that is fed by the buffer, and if you are, let's say, in transmit mode, the received data will still be shown in that register just for a second, like a double buffering. First byte received in. Also, there is a command mode, and I don't know. That would be amazing if we can have like an extra command. Command mode. It seems like the first byte is the command, and then you have data or whatever. And I'm wondering how that works because there is no further description on that. Yeah, if I want to do the CRC, I don't know. That's like extra bytes that we can avoid. The CRC is good for the firmware, but there is nothing really that crucial that would require CRC other than programming the new firmware. FIFA overflow, DMA, SPI, and single byte transfer. Reserved. Current byte. What is... Yeah, that's reserved. So... Oh, yeah. It needs to be 4 bits because you can indicate that's 8. SPI data FIFO register. SPI buffer. Okay, reading SPI means to obtain the data from the last exchange of SPI. It does not affect FIFO count. Writing. Oh, so there is a buffer. This is interesting. Maybe we can do like almost a full duplex if we use but it says exchange, so it's not a receive. Writing to SPI buffer is in master mode. Okay. Reading SPI FIFO. Writing slave mode. The external SPI decides when to take it. In master mode, the transmission blah. But what is with SPI buffer in slave mode? It's not defined. Okay, yeah, all right. So no actual full duplex through the back door. Okay. Yeah, and there's some DMA. Transfer formats, SPI configuration, slave mode. All right. Nanoseconds, maximum 24 nanoseconds, it says here. Okay, that's that. So let's define client always in receive mode. Host can fetch data, ports can request fetch, then puts client into send mode. Maybe we do it very simple. There is a safety, basically, which is timeout. Timeout resets to receive mode if no fetch happens. So we are safe. Client always in the receive mode. Host can request fetch, puts client into send mode. Timeout resets to if no fetch happens. What we can do is, do we want like a low level fetch or a high level fetch? We can define it like that, since we can send like multiple bytes. I would say if we do a fetch, we can define memory address or buffer address or whatever, and what kind of data is in the buffer, I don't know. So it can basically fetch, it's slow, but it could fetch like 8 bytes by 8 bytes, since the FIFO is like as big as that. So fetch sends 8 bytes from hey Johnny, thanks for the resub! From requested address, like for sensors, and then there are different modes. Just sending something there. Maybe we rename that CRC. Ah, Caspar, you have okay. That's yeah, several bytes. That's good. We can define it like that. We don't need like to check the CRC yet. Oh, the good part is about level 0 is if we run it from completely from the SRAM, we can overwrite the flash while it's running from the same location more or less. Like we can overwrite the code that's currently running because it's a copy that's running from SRAM. So level 0 is we don't need an actual new bootloader if we don't want to run it safe. Otherwise we would need like to have like a specific section for that. Address. Okay, so we have, it feels like I need a new sheet or something that specifies the protocol. So let's add a protocol here. That's a new sheet. Rename SPI protocol. And half duplex. We have host. What is happening? Okay, host months dummy that's basically that's description. Yeah. FD. Yes, that would be basically what I think is the let's say the beninging, in the beninging. Description or function, and then the description used when receiving. What complex coding? That is not very complex. It always like starts, the data is basically a stream of bytes, and the first bytes is the comment, and we can basically define what the comment is. So if we implement that protocol, both the host and the client, 40 years of coding experience. It's not 40 years yet, 35. For you, Caspar, it is probably. FD is just the command. We can define it however we want. And say fetch data. Ah, nice, FD. Fetch data. But do you have something for read? Because we can do read and write. I would now read, or let's say let's start with write. Do we write or no read? Read, write. Okay. Uh, 6, 7. Yeah. 6, 9. 6, 9 and 6, 7. 5D. Send data. 5D. Oh, live. Don't tell me this is like an unwritten rule. Unwritten rule. Send data. So 5C is read data then. Six, 7, 6, 9. It can be whatever we like. It doesn't really matter. We can fill the codes later, but it's quite cool that you have like suggestions. Magic number, bad food, like bad food. Bad food and reset. Hey, Mr. Wu. So read write. What do we what else do we do? Structure. Dead beef, yeah. Maybe I will move the description elsewhere. It's structure. Structure is basically or payload. Payload is nothing. Or let's do nothing. Or let's do 0, 0, 0, 0, 0. It's always 7 bytes. Let's assume it's 7 bytes. We can make it, keep it shorter. 2-byte address, because 256 bytes is not enough to map the whole address space of the 12 kilobytes that the MCU has. We could even take more for the other ones. So if we do read, basically start length, we could do 3 bytes, like address 0, let's call it like that, or basically I think yeah, 15 8. And then Luniasm. Yes, we can do Luniasm. How do what was Luniasm didn't have, like, I mean, this is the protocol. We can still run Luniasm on the device itself. We just need to upload the firmware there. And this is the first step. Oh, you can find it on my GitHub, I believe. There is also a web browser that's an assembler. That we developed, and there is an implementation for that you can compile in C++, I believe, and put it on any microcontroller. Here we go. This is your address high, address low, 227, 12 kilobytes. But that would only work, save a whole byte. Yeah, that would only work for this one here. Luniasm? Yeah, here we go. Thank you, Kasper. Function first, and then we can still optimize. That's why I believe we don't need more than what's still happening. We don't need to more than that address, and then maybe length. But how do we fetch page count? Oh wow, that's yeah. And I still have the we need to continue with Looney as in with the little devices. It was so cool. We could even upload. I mean, Fu used it as well, I believe. Or did someone use the code? We were able to use the CH, what is it, 32x35 as a file storage device to put compiled Looneyasm code on that and run what is it, Game of Life and and other games. Oh, that was crazy. I think we didn't have we only have Game of Life, which was an actual program that was running, someone wrote. That was fun, yeah. I'm looking forward to do more fun like that. Maybe we should vote again for stuff so I don't fall into traps like this huge project here. Address and then length. Or do we send it all the time? No, it's we can fetch focus 16-bit error here. Okay, we can do that. That's only 4 bytes. We don't expect more, which is alright. We can optimize like that. There will be always after each block we need to measure the time that the MCU needs to process what we do here, because when I programmed this communication here, actually I noticed that I need to put everything into high code, so basically running from SRAM, because it wasn't able to fill the FIFO in time, or like increment the variable and put it in the FIFO whatever before the next frame was requested by the host. So what we see here is the byte that the host sends, which is here, this is like the first row is the host byte, is completely ignored. It's just taking care of sending because it's in sending. Oh no, wait, we uploaded the new code. So yeah, wait, didn't we upload the code? What happens? CE, CF, CD, D4. I think we uploaded a new code. 0, D3, D CD, D4. Yeah, it's almost like it's inconsistent. I have no clue. We didn't upload, I believe, the focus. That was, we uploaded to level 0, but we didn't to level 1. So basically what we do is that, but not this. So receive host, we need send who is not sending anything, or is it sending it? Oh yes, send. Yeah, receive does nothing. So we need to increment here receive r plus plus send and then increment. So let's do that, upload that. So what it will do right now is, yeah, it's still blinking, and now let's see at not the yeah, it's incrementing 1C, 1D. Oh, yeah, 1A, so that's hex. 9A, 9B, and the bottom thing is actually, why is it still like sending anything? I thought I uploaded it. Because why should level 0 send anything? 18, 19, it's behind. It's just receiving whatever we received, like the old FIFO values. It's just sending crap, which would be weird. Why do we receive anything from the client? I don't get it. Okay, let me reprogram it. We shouldn't receive anything from it. That's level 0. Receive SPI client. And we send something here. We don't send anything now. I need SPI client. Receive. Okay, let's see. Yeah. Now it looks like we're receiving garbage here. Not sure yet. Nope. So weird. Huh? Yeah, I know, but I would think that we were able to send dummy bytes while we're in receive mode. Or FF or whatever, like, so we are not sending anything. There is no send here. It's receive, which is weird. Let's check the datasheet, what it says. Master mode, okay, slave mode. First byte mode or data stream mode? Set FIFO direction, configure FIFO direction. If it's 1, FIFO is used to receive. If it's 0, it's transmit. MOSI output enable. SPI seek output enable. Control mode to 0. And set MISO output enable. Okay, so maybe we need to disable output enable. CK control MISO this flag to make SCK as an input. Switch to output after chip select, one master with slaves or output. In SPI slave mode the IO pin direction of MISO can be set as output by GPI direction configuration. It can also automatically switch output during period but this output that I selected by it's recommended to set MISO pin as input, so SPI bus can be shattering. Okay, yeah, that's clear. 2-wire mode, 3-wire mode. It's interesting, if we do 2-wire mode, we don't need like the hardware fix. Is it? Wait. I think no. Yeah. Okay, optional, set the preset data register SPI 0 slave mode. No. Used to be automatically loaded into the buffer for the first time after chip select for external output. After 8 clocks, that is the first data byte is exchanged between the master and the slave, the controller will obtain the first data byte command code sent by the external SPI host, and the external SPI host obtains the preset data value through exchange. Oof. This prosa text is really tiring to read. No. Okay, it's weird. It seems like the FIFO that we... Yeah, same here. My evening brain is not capable to comprehend that. It looks like it's basically outputting also the FIFO that it's reading. So the bytes will be just bounced even though you don't ever send anything to that. so weird. Yeah, it's 8 bytes. Eight bytes behind. So it looks like it's sending any receive. I'm wondering if we can configure it such that it not doesn't receive R8. R8. Let me do that. SPI. Turn off SPI buffer slave pre. Okay, so let's see if we can do that. If that changes anything. But this is just for the first, there's nothing. That's only the first bytes. It doesn't do anything. What else do we have? Control configuration, control mode, FIFO, interrupt, run flag, control config, SPI. That's the direction control. We need to find out what that does. Control configuration, register, control configuration. Okay, Miso Mosi output enabled. Yeah, we could turn it off, but input, output. Bye bye. First byte mode, selection, slave mode, command mode. But what does it mean? I mean, I never saw this in this command mode. It's not like there is a register or I can get this command or anything. First byte of data after SPI chip select is valid and SPI. That's the SPI will be set to 1. That's only probably for the interrupt, and it doesn't matter what else it is happening after that or whatever. It's just for this interrupt. I didn't see anything else about the command byte. Master clock, SPI2 wire mode, selection, full duplex. It says we can do full duplex. Default is full duplex 0. You know what? I'm wondering what we receive is 8 bytes behind. What if there is a way the FIFO works that we can do full duplex by basically writing the FIFO here. So receive byte. What if we read the byte? That's okay. So let me check that. If we receive SPI client, what happens if we do the following? Opala R8 SPI on FIFO write 8 bytes. Do you think we can if we have the FIFO? Okay, let me do. Let's just test this. I'm curious. Maybe we can use full duplex. You swear you saw something like? Oh. What did I do? Oh yeah, here. Config. It's not config anything here. What if we have 8 bytes and if there is like incoming data is just flipped with the outgoing data, so we can fill the FIFO with crap with our outgoing data, and when we receive it, it will be replaced in the FIFO. So it really doesn't matter if it's like in, out, or whatever mode. It might be just like the order or that's change here. So did I upload it? Yeah, okay. So let's check what happens if I just replace that. No, nothing. Okay. That doesn't work. Okay, so let's change the FIFO direction. Okay, let's do that. Hey, ITT. Let's change the FIFO direction. Maybe that. Oh wait, did we upload? I don't know. To see. Oh, we are onto something. Peeps, we can do full duplex, I believe. Uh-huh. This is with 1 byte. Does it work with multiple bytes? Oh, you sleepyhead. So there is a way to use the FIFO in both directions, is it? I'm not sure. I'm not sure what we read here. I need a slower. Okay, there is a way of full duplex, it seems. There is a way of full duplex. Maybe. I need to hack that. That's weird. They don't say it works, but it might be possible. Like that. Let me check that. It says full duplex. But it's weird if you switch that the FIFO to read or write. And probably if we have DMA, that won't work. Okay. I give up trying to understand this. There is another thing that we can do. Basil seems to be offline. I know if we can do implement. We should finish our notes. Okay. You're here. You're listening. All right. Okay. So. Oh, that's all right. That's all right, rather. You're allowed to eat the. Okay, right. Yeah, that's basically it, and then it would expect. Oh, what happens if we write data like that? Can we write like 7 bytes? That feels weird. What if we write? Oh wait, we can address and then do. Yeah, we can do that. The issue is, can we do? Can the client process it in time, or do we keep it in frame size? Oh, you're right. There is one thing. Forward, and then client. Ooh. And the next block is then what? Oh, that feels so bad. We need to handle packets. Like if we add that and then we can unpack that. Yeah, you're right. No. I want to. The protocol needs to be extended like that. So basically, packets. That's the hardware layer. I'm not sure if we. 56. Yeah, one comment byte, but oh, you mean that? No, but we would need to wrap it. So if we have, let's say, if we have let's say that's forward, then we have we know we need client 2.0, and then we have basically what's following is the packet. We have many levels, so we wrap the packet like that. That's the data. Maybe there is even like an optional CRC, and inside of that is another forward. So this has now variable length, and there, let's say this is forwarding to that, and there inside is the comment or whatever. But this feels like it's another layer. That's the logical layer where we can address, like, send data. The hardware layer, number of layers, no, that doesn't matter. We have an infinite. It will always unpack it. Yeah, the maximum layers, the maximum targets is currently 32 individual targets. The payload starts, like, the first byte indicates what it is. This is the forward comment. So yeah, this is basically, it forwards to the next layer, and this is the client ID, client number, whatever, and it forwards only this from inside. Oh, we need to, maybe the length is missing. Length len plus 4, and then we have whatever length len yeah, it's just so when let's say we are the processor, we receive the packet like that, we see, oh, I need to forward the next bytes to this client, this is the count of bytes, then it will just either, I don't know if it waits for the CRC, it can buffer the whole packet, or it just start forwarding it in the command byte. Yeah, if that's enough, if we have like a variable length, you mean like we can if we have like 6 layers in the end, then the length is quite restricted at some point. Let's say we use 4 bits for the comments, then we have like 16 bytes, and then we have 4 layers, and then whatever, each byte, each layer takes like 2 bytes for the client ID and the comment. It's just recursive. 16-bit words. Well, we can do that. It supports 16-bit. I believe it supports. I don't know if the lowest one. I think that supports also 16-bit. Does it? 8-byte. No, it doesn't say 16 bits. The other ones supports 16-bit. Yeah, you're right. The destination. You're right. Yeah, you're right. That's perfect. Yeah, let's remove that. +3. That's just recursive then. I hate that it's 3. What happens if the packet CRC? Oh yeah, you mean like that? You're right. CRC. We would need to CRC the destination then. Yeah, you're lost because, oh yeah, all right, okay, so here is, this is where you see the first 3 layers of the ITT. So this is the botched version of my, this is the interface test boards. It connects, these are the programming pins. These are 512 MCUs. We have level 0 is 32 MCUs that are connected over SPI to the controller. We have 16 row controllers that are connected to level, that's level 1, that's connected to level 2, and there will be more levels and levels. So our protocol, I think this is the soft protocol. There is like this hardware layer. I believe that's just a different layer, and however we implement a logic layer like this doesn't really matter. Comment ID, length, ID, address, low, address, high, len, CRC. Yeah, then this is now mixing the logic with hardware. Yes, there is the jig. That was the plan for this stream. We can start making the jig right now as we speak. Here. This is the jig. This old, non-functional anymore 3D printer. We have one. Let's give me the. I have one PCB, MK2. It's MK2. I'm not sure if it's big enough. Like the issue is I have a printer that I made, but unfortunately the Z-axis is broken, which would have a build volume that's large enough. But I'm not sure if we can we can address like each of the programming pins correctly. Okay, it fits. Let me move the camera. Look away. Look away. No, I can do that and then move the camera and then here. Alright. Okay. This way around. Yeah, this is not possible. We can't address like that. We can maybe do it like that. The issue is, okay. Oh. Okay, this is the maximum extent. I need to power it up and control it. Oh, we have a super chat. Johnny! Brain Rot Fund. Thank you very much. 667. Here. 6-7. Thank you very much. Alright, so shall we just send a few G codes? I believe we can send G codes over serial. So let's try that. I have a long cable here that I will be able to use. Yes. I need to put, this is serial, and then we will try some G codes. Okay, power. We need some power. The topic changed like in an instant, huh? Alright, we don't need the soldering stations anymore. Let's unplug that. Oh, this cable is not long enough. Oh, here's an extension cord. Nice. Let's use that. Oh. It is even powered, so we can use this extension cord here. Let me change the lens so I can zoom out. This is not a zoom lens, this is... Yeah, now you're invested in the test points. That's the programming pins. And we are now making the jig with G code. I would say we can use, even though I'm not a Python dude, we can use Python to run basically serial and then execute the programming from shell. Yes, they're all like exactly spaced apart. 5.4 millimeters in X direction and 16 millimeters in Y direction. It's all, I designed it. I know how it works. We need just maybe a frame for that. Yes, that's what we do. Alright, power is here. Let's power it up. Turns on. Woohoo! Okay, let's control it. Yeah, this is more interesting than trying to figure out a protocol. Hey, Hugh, I missed you. All right. Um, Serial. Can we do? Is there like a G code? There's probably something online that we can use already. Web serial G code. Yes, I know, I know. 3D printing, utilities, terminal, extruder steps. What is this? 3D printing tools. Voice to G code. Huh? Okay. Found a tool. Connect. Which one is it? Oh. Okay, I found the tool. Original Prusa. Starts. G code? Yeah. It's Marlin based. Common G code. Wait. Is there no arrows? Yeah. Let me use that. Sonic, thank you. That looks more. Oh no! I thought that's the. Oh, yeah. Okay. Let's do new one. Okay, you know what? Let's write a prompt. Write a web serial terminal for, not web serial tool for sending G code. Show add arrows to move X, Y, Z. Yeah, we'll do it. I just want to one tool to start testing what home, and then show location in a little, I don't know, canvas. Something like that. Let's see what it does. Oh, it's fast. I should do thinking. Jog. Feed rate. Yeah, let's see. What is this? Yeah, that's what I want. Okay. Yes. Okay. What? Give HTML. Pronterface. Yeah. Thank you. Give me a link. Holy. What does it mean with localhost? Okay, let's copy that. Drop it somewhere. Ultra code. CNC control. Anti-gravity? What is that? Okay, let's see. Okay. Should we try it? It does the homing. Oh shit! It touched my PCB. Ah! Bed leveling failed. Yeah, I need to disable the bed leveling. Alright, let's try again. It says it failed the bed leveling. Okay. Home all. Let's start again. Ah shit, it's in a fail state. This is 10 years ago. You made a fortune by developing this interface. You wouldn't even know. Okay, it's oh shit. Now I emergency stopped. Killed. It's killed. Look at that. We can show the display. Ah yeah, you can see the times. Yeah. Okay, home all. No. It's killed. Come on. Okay. Okay, now it restarts. It's so cool. Oh no, it's homing. I don't want like bed leveling. Yeah. Universal basic income would be nice. Okay, bed visualizer, that's so cool. It you just add one half sentence. Oh yeah, add a canvas that shows the position, whatever. Okay, Z up. Okay, it even shows up. Yeah, that works. Okay. Okay, X is a little bit weird. The placing of that. Oh shit! I hit the stop. Okay, I hit the stop again. Okay. Oh, I can't do that. Oh, that would be cool. Okay, let's let's add this to the prompt. But we don't really need it. I mean, we can always. Nah, we don't need that. I wanted to test if we are able to. What is the? Okay, this is Max. FBI protocol. Yeah, right. So, okay. Let's check how far we can move it. Where's my tape? Okay, I can use the blue tack. If I can play. Where's the blue tack? Everything is gone. Bytecoding. This is alright, so this is our mock-up for yeah, okay, so let's assume this is our pogo pin programmer. Now let's move. Let's see if we can act. No, we can't. That's not sufficient. We can't program using that axis. How about diagonally in two halves? Oh no. Yeah, you're right. No, I don't want the minimum effort here. Let's put it like that. Let's assume we can do it like, can we? Okay. No, it's not complicated. It's always in fixed offset. You just need to do that. This is maximum that we can do. No, doesn't fit either. Okay, so vertical. Not doing vertical, okay? Let's see if diagonally we are able to reach everything. Nope. Redesign the card to fit the print pad, that's cool. Yeah, doesn't work like that. I have my other printer downstairs has a build volume that's large enough, but the y-axis is not great. Vertical travel is, yeah, no, we're not doing that. That would be like the pogo pins, and diagonally is like really a stretch. I rather take another diff CNC then for that. It's also not good enough. Yes, we can always do it. It's all just G-code. Alright, I mean we could do in 2 passes here before I have a different solution for that. Let's start with one pass. Now rotation by 180, I will just shift it by half the blade or something. It would be better because then I don't have to change anything. It will be just like that. Okay. So it's interesting. Yes, I know. I need to print a jig for that, so it will always be perfectly placed. I'm wondering G90, G1 is relative. I think G0. Print a geared add-on top of the bed. Konstantin, yes. I will put another printer on the bed of this printer. Which will do the job. Yes. A printer on the printer. Perfect. Or I can just remove this stop. Is it physically possible to move it more if I remove the stop? Nah, it's okay. In this direction, it's not. Let's do it slowly. Pantograph. Oh, a pantograph. Or how about I'm lacking of y direction here. Okay, so I have some points beep 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 beep. Oh wait, no, they are vertically placed. Are they? Yes, vertically. Okay. Let's say like that. And I have this chunky big printhead. I can remove that. And I have the pogo pins here. And then I have a second set of pogo pins attached to the same wires that is only shifted slightly that it will, like if we have like in X direction, that because the pins are all like in the square manner, that the second head, like this alignment of the first head would be like that. This is the alignment of the first head, and the second head is just shifted by no, because I want to do one by one, so I know what the issue is. It's a good idea to have it like twice as fast, but if we like if the alignment is slightly off, it will miss the pins that are not targeted here. But I know No, I not. It's always with the. I don't. That's. Don't overthink it. Yeah, but electrically it sounds like a lot more work than just adding a slight X offset, and then just by both are connected in parallel like that. So I don't need to do anything electrically. Same linky. Same linky. I'm smart, huh? I surprised you again. The only thing that I need to change is add like 5 millimeters in the G code, and that's all. And then I know it's shifted by like the other set of rows that. And now we have enough space. Like even though if we can move only here, we can still reach over there. That's the solution. That's the solution. Easy peasy. All right, all right. Good one, DFGA. Causes of shorts. Yeah. What do we do? Back to the protocol, or do you want to continue with that moving and programming? Yeah, live. That's what this was about. That protocol that we just started to do here. You know what? Let's do that. Maybe 7, 8. Oops. 2 boards. Yeah, I don't think I need that. 31, 24. Address, read. We can read and write. No, this is right. Oh, no, this is read. Shit. Right. Good night, Jordy. Address, write, and otherwise we just receive. That's it. That's it. No forward. Dummy. That's the lowest level. Just writing 4 bytes at once. Read 8 bytes or 4 bytes? 4 bytes. With 4 bytes in next frame. We can do 8 bytes. I don't know. Oh, maybe we can detect CS change. If chip select changes, then it just fills it. Next, just writes the count of bytes. If we can do full duplex, it doesn't matter anyways. I mean, we can do whatever. Read, write, data. First byte is what it is. Yeah, I don't know. It feels like my brain is not working anymore. It's 11 o'clock. I'm doing quite a lot today. So, oh wait. For protocol, no. I want to have full control of that. I want to keep it simple. So, what do we need for the firmware? We need to fill a buffer and write it. Fill a buffer, verify that the CRC or whatever, a checksum, and then write it to the flash at a specified position. What is the flash frame size? Flash. Yeah, but if you send it again, and let's say you have like one bit is always broken. Oh no, it's serial. Wouldn't do. Ulu. Causal making. No, it's never causal. Flash ROM. All on chip data. Flash ROM code disable. Flash ROM control. Flash data, word site register, flash data config. Okay, we seem to be in the right section. Nah, this is independent of that. Power on reset, soft reset, watchdog. And they don't explain the system stuff. At the same time, that's interesting. So, if we wanted to do that to save basically bandwidth on the higher levels, then we need like a flag, either a bitmap or a broadcast command would be a thing. So if you do, let's say you have forward or you have broadcast. Broadcast would basically transmit it to everyone, but in that case it might happen sequentially, because broadcasting can be dangerous since the clients are enabling the MISO. So either it has to be, broadcast has to be announced, so they won't enable MISO. Then that is possible to send to all the clients at once. Ulumulu, if you have an ESP with 512 cores, then yes. Okay. That would be very expensive. With ESPs, yeah. I still have maybe even 100 ESPs here. like the module, I think S2 modules, the original ones, don't have as many S3 modules here, but I think at some point I bought just. Yeah, but we have something better than that. We have code. We have all implemented code is better. Code is the actual documentation. Here we go. Okay, flash ROM read, start address buffer, bop bop bop. Interesting. It's just mapped. It's just mapped. It's just mapped. User option byte config. It does all the magic. If you want to write an option byte. It could be. Ulumulu, you can write. Assume it's 65,536 cores. And they have a multiplier, unlike my previous clusters. That's the goal, actually. Get unique ID, user option bytes. Now, where is the flash user option? Flash ROM read, but where's flash ROM write? What? Oh, it's not implemented here. Oh, flash is not implemented. Flash write. Okay, get unique ID, but flash ROM read, go to definition. That might be. Where is this flash ROM read? No, there's no flash ROM write. Flash EEPROM. Oh! ISP 572 flash. Software reset get MAC address. That's only the header. GPIO, let me check. That was flash. It might be a challenge actually to write something to flash. Let me check if there is something in the example codes. It's probably just implemented on the spot. Oh, what do we have? Added support for downloading debugging functions. Flash block size. 4 kilobytes blocks. So this is what we need to write at once, 4 kilobyte chunks. Updates, built-in ship, project template, okay. Utility, yeah, I have this one here, the 470. Where is it? Here. That might be actually our interface to the outside world from the cluster. That's the 417. It has even Ethernet and some USBs. I think that one of those should be USB 3. Yeah, not yet. Let's not update that. Okay. Flash ROM. Flash ROM write. Where is that? Oh, wait. That's a define. Extern. Bastards. They put it in a library? No. Objects. Wait, where is it? Oh. Ah, you evil Yeah, it's not here. Yeah, it's not a lot of code. Can someone disassemble that? Decompiler Explorer. Okay. Is this the magic bytes? Wait, where is V1 coming from? Oh, that's the first parameter. Pointer S0 SA. Why does it add just Great erase, binary ninja, sub 240, okay. Yeah, it's weird. It's a magic address. What is this in hex? That looks like it's a register. What is? Yeah, give me the hex. You found it on GitHub? That's the address. Let me check. The address is yeah, that's like an weird address here. It doesn't look like wait, let me check if there is a map. Memory architecture. Is there a map? Reserved. What is this extension? Assistive controller. Proprietary extension. Negative number from pointer. Oh, you mean... You're right. It could be... Yeah, it's just subtracting here. Big... What is this, by the way? I mean, is it used? It's just a negative number. But why is it 0 then? And okay, we have S0 is the pointer. Slash from begin. Yeah, no, it feels like it's a sequence. It's a sequence. It writes the sequence that seems like it's in register or something. 0, 5, then it writes whatever it writes there, and then do while whatever. Wait, begin FF. Yeah, that's just a begin. It waits for it to be ready. V1 is a register. That's like a stack frame or whatever that is passed. So if there are like arguments, it might be that pointers are passed in S0 and arguments. It's a register. You write a register, then you call the function, and then it expects it to be. It's the same like you would on x86. You would expect the return value to be in AX, DX, whatever, EAX, EDX. If you have like, yeah, I believe that it's. Oh, is that like the 64-bit extension RAX? I stopped with x86 assembler while there was no 64 bits yet. Yeah. We can see basically if we use that and we go to the code here, we can see the. Oh no, it's not there. Sonic is still at 8 bits. Yeah. We need to find. Flash ROM out, flash ROM in. Yeah, there is a such. Yeah, no, it's not found. Either that or I don't use the search correctly. I don't. I'm not sure we got this decompiled because it's complaining. Comment write. No decompilation output for. So we're missing a few but those here, which is unfortunate. Should we do more? Okay. Yeah, anger was okay. Binary Ninja failed. Boomerang, Devolve, Ghidra failed. Hex Race failed. Reg, Rico, Realize, Red Tech, Ref, Snowman. That sounds like a hacksaw. Error, 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 error. Okay. Anger is still the best one, but it fails to decompile it. Can we check the structure of the file? Flash ROM begin. The table ISPO. Where are the addresses? Are those the offsets of the functions? Why isn't there object dump? It's not here. Or I use that. It runs Ubuntu. That's an ad. Oh no, I have an Ubuntu desktop now. Wow. Can run everything from cloud. Oh, right, alright. We can run it. Where is the output window? Or should have. Terminal. Ah. Oh, I'm getting tired now. Was so energized. Now I'm struggling. Git bash. Okay. Let's go. Oh, you know what? Nah. Oh, I didn't compile it yet. Let me compile that. And then see what we get if we decompile the object file here. Here, main. Let's drop this here. I have a better idea. How about Um, oh, we have the printer connected. There you go. That's going great. Okay, we can just run the disassembly and we get all the code. Here we go. Wait! We have the assembly in the output folder, don't we? Isn't that the... No. Startup object. Or do we need to set this? Are we trying to disassemble the flash stuff? Messing with low level, yes. Trying to find out. Okay. Yes, yeah. Okay, so where do I find as the assembly build steps artifacts? Generate assembler listing? Is it that? No. That's just linker. Okay. Okay. Let's stop that. Now I need to reprogram my level 0 again because that stopped working. I hope I don't... Yeah, it works again. Although the blue LED looks weird now. Might be interfering with it itself, with writing FF all the time. Yeah. Alright, the listing. Flash Oh, that's only, yeah, I don't. Oh, here we are. Yeah, here we go. This assembly. Sys, that's all sys. No. What was the flash ROM out? Flash ROM right. Oh, come on. It's still all jump. I tried to find command buffer. How that works, the flash, because we don't have the code for flashing anything here. What is this? Oh. Flash E from command. Where is that? Yeah, you're right. It needs to be linked, so the library is built in, statically linked. Huh? Eh? Didn't it copy it? Aha. ISP. Extern. So this is already in the this is already from the library, it seems, because they say it's external. Flash command. EEPROM commands. Wait. Minimal quantity of write or verify is one double word. Initially, that's all I wanted to know. In the listing we can already, but why is it, did it generate this disassembly? Because that is nowhere to be found in the code. Yeah. Blah blah blah. Okay. Oof. All right. Yeah, my brain is not fresh enough to analyze all that code. Especially because I'm not proficient in RISC-V. Load word, load word, load word. Stack pointer. It's happening a lot of on the stack, like variables or whatever. Oh, really? It's quite a few loops. You know what? Oh no, I need to. I need to compile that. Either I put it in. Yeah, because I can't. I can't put it in SRAM if I'm not in control of the code, because that's like an external library. So I need an actual section for a bootloader, which is bad. I don't think the interrupt vectors have an offset here. Let me check that. Start up. Vector base. Oh, Darren, sorry to hear. Vector base. Okay, let me check that. Handle reset. So code always starts in this base address. I think it's 0 on this this one. Yeah, and then we need to find out how it sets the vector table, because if we run code from another section, we need to have also the linker script be modified to start at the section, but also the vector table. So handle reset global pointer. Where is this defined? Is this in the linker script? Global pointer, okay. 800. What is that? Data section. VMA. BSS. Ah. Section. High code init align. Oh, I need to learn how to read those files. It's interesting. There's so many sections. I know, like from PE files, there were like, or from assembler back then, there was like data code section, and maybe I don't know, read only, which was quite often also the code section. Initialized data. No, there were but here constructors. Okay. All right. Where's the section flash to RAM? Okay, clear BSS. What does that mean? That the empty vec, that sounds like a vector table. Let me check the translation. Configure the vector table mode absolute address mode. So it sets it to 3. Vector table starts option word 0. That's basically handle reset. Jump is a relative jump, and that's only 3 bytes or what? And then it starts here. So what we need to do is basically change the vector table to begin wherever our new code is dropped. Oh, that's so weird. Okay. No? No, I want to have a bootloader that loads an application into a and then it just loaded to 2000 here. That's no, this is to run everything from nah. Yeah, but the code will always start from that. I mean, I could do, let's say, I would origin the flash from, we have 240 kilobytes. Let's start from, uh, if we change that to that, then it will compile everything to start at the absolute address of that. Then we have 64 kilobytes for our loader, and then we just need to jump to this address then, and then we are good. Am I right? Yeah, 64 or whatever it is. I mean, it's not big right now. So that's what Gemini said, more or less. I mean, I just needed a suggestion. The only thing, yeah, I guess we can put the bootloader in the beginning and then just prevent page 13. Okay, 0. Yeah, then we have some reserved data SRAM. What is this? SCS debug fake flash control. This is what's happening at 41800 whatever. Yeah, I don't care if it's fast or not, or small or not. We have more than enough flash. We just put it somewhere. If we look at what did it take for where is it? I have it here somewhere. Here, ultra code. Oh no, it's not here. Where's the code for the stuff? Level 0. Come on. Oh yeah, that's the wrong folder. Anyways, we need, yeah, 42 kilobytes, but this is like, oh no, that's actually the byte code. 40, yeah, 64 kilobytes might be reasonable, but this is basically all the static library linked in. It's all included. That's the hex file. Hex file is... Huh? Wait. Hex file is 5 kilobytes? Alright. So divided by 2 and we are good, like with SPI initialization, we are good with like 2 kilobytes. So I mean, we can be wasteful with our bootloader. We have enough flash and do that. And I think as soon as I got an SPI working where I can flash firmware, basically 250K altogether is like crazy. That should be enough for everyone. Yeah, as soon as I got that working, doing like a flashing method and then jumping there and running it and it works, then we can do whatever. Yeah, that's what I meant, Johnny. Alright, peeps, I'm tired. Uh, yeah, hit parser, 30K. Yeah, I guess we probably need only 4 kilobytes in the end. But I don't know what it links. I mean, it links like this the whole flash thingy. Oh, 15 gigabytes. Wait, what? Then 40 times. Yeah, 15 gigabytes of flash in total. Alright. It's not bad. Super SSD. Yeah, and then you have just on the top level, you have just a SPI 24-hour stream. I can see that happening. I'm so tired. How can somebody be so tired as I am? Alright, peeps. I keep you updated. I think we are on a good path. I need to fix. No, I need to. As soon as I got the flashing over SPI done. Yeah, I'm just old. Always just tired. Um, 20 years. Oh, you know what? No, that was like 5 years ago we did old man noise. Okay, fool. Oh, you recognize like, and then when you move, then you hear the cracking. Let's hear some cracking. I give you some cracking noise. Ah! Oh! Oh! That was just. Oh! That was my rib cage. Ah! Maybe I will stream this weekend. You peeps are eager to see the progress, and it will be amazing to see how we can program using the printer. How we can program. Oh, you watching the revision entries? Oh, that's cool. By who is it? Oh, that looks cool. Oh yeah, that's amazing. What fabric simulation? I guess the simulation is quite easy to program because that's like only a formula more or less, and then you just need a few like spheres that microcontroller class in the revision. Really? I don't know. Yeah, I know. But there are such great synths already on 4K intros. That's why they try like to implement now 8K because they can basically run all the demos in 8K. Wait, what do you mean with is there? Is it running right now? No. Revision was at Easter. So it was like oh, it's over. LFT entry for Pi Pico, nice. Was yeah. Yeah, missed some revision. I mean, Easter holidays are for family more or less. I had really fun this weekend visiting family and spending with Tony, and we had like a huge in the village we had like a 10-meter high bonfire. I show you my villagers here. I show you a picture of my villagers. Saarbrücken? Yeah, that's not here. Uh, that's the bonfire, and in the background is the village. And the pink jacket, that's Tony in the front. That was a 10-meter high bonfire. Here, even here in this one, a scale. Here you can see even more. Like it was like so yeah. So basically, they collect even. I brought two and a half trailers of like wood and stuff from my garden there. And what's happening is like the whole village collects all the Christmas trees and stores them for this bonfire. So we had like plenty of dry Christmas trees and everything that you got from garden there. Everyone dropped their stuff and I put it on fire. It was cool. All right, peeps. I see you next time. I'm tired. I hope you have a good night and sleep well. Side load saver. Yeah. All right. Bye bye, everyone. Have a nice one.